The Great Barrier Reef is a valuable ecosystem which has been exposed to climate change. And to help corals survive, Australian scientists are trying to speed up the reproductive cycle of the corals and boost their genes, which can survive higher temperatures. Take a look.
Below the turquoise waters off the coast of Australia is one of the world's natural wonders. An underwater rainbow jungle, the Great Barrier Reef. Billions of microscopic animals called polyps have built this breathtaking 1,400-mile-long colossus that is visible from space and is perhaps 1 million years old. It is home to thousands of known plant and animal species, and it boasts of a $6.4 billion annual tourism industry. Battered but not broken by the impact of climate change, the ecosystem is inspiring hope and a worry alike. And that is because researchers race to understand how it can survive a warming world. The underwater heat waves and cyclones, driven in part of runaway greenhouse gas emissions, have devastated some of the 3,000 coral reefs that make up the Great Barrier Reef. The heat waves in recent years drove corals to expel countless tiny organisms that power the reefs through photosynthesis. This has further caused the branches to lose their color or bleach. Without these algae, corals don't grow and can become a little brittle. And without time to recover between these events, the reef was not able to regrow. The researchers say that climate change is already challenging the vibrant marine superstructure and all that depend upon it. And the worst is yet to come.
At 1.5 degrees of warming, with strong local management to boost resilience, we think we can protect coral reefs in many places. But as we approach 2 degrees, and certainly as we pass it, we will lose the world's coral reefs and all the benefits that they give to humanity.
The authorities are trying to buy time for the reef by combining ancient knowledge with the new technology. They are studying coral reproduction in hopes of accelerating regrowth and adapting it to handle hotter and rougher seas. For 37 years, the divers with cameras have built a record of change. Disasters got bigger and happened more frequently. The first step in the reef restoration plan is to better understand the enigmatic life cycle of the coral itself. And that's why dozens of Australian researchers collect coral eggs and sperms during the spawning event that is the only time each year when the coral polyps naturally reproduce. Back in the labs, they test ways to speed up the coral's reproductive cycle and boost genes that survive higher temperatures. One such lab floats off the coast of Connemara Island, a 2-hour boat ride from the coast of Queensland. 20 scientists and staffers are collecting coral for study for nearly a month now.
Our current target for the coral seeding intervention that's being developed is to deploy tens to hundreds of millions of corals per year. And so the research that we're doing here is looking at how we can upscale, how we can deploy large numbers of corals, and where we should be deploying those corals to maximize the chance of survival and success of the intervention.
The scientists compared this method to tree planting with drones, but underwater. Meanwhile, the scientists at the National Sea Simulator have successfully bred corals in a lab off-season. A crucial first step in being able to quickly and at scale introduce genetic adaptations to climate changes like warming waters. For now, reef-wide farming and planting corals is a plausible science fiction, as it is way too expensive to scale it at a larger level. But in the near future, it might be possible to carry out these methods. And until then, we as individuals have to cut down on our emission to save these reefs from going extinct. Bureau Report, WION World is One.
WION World is One is now available in your country. Download the app now and get all the news updates on the move.